All right, so welcome everyone to the breakout session for R users. Hopefully, most of you have used R to some extent before, and if not, that's okay. Consider this my pitch for you to join the dark side. Uh, I'm Matt Gunther, and I'm a senior data analyst with IPUMS PMA. So I've been with IPUMS PMA for around 5 years, I think, and my role is mainly providing technical assistance to the research faculty and postdocs and grad students on our team, at least those who use R. We use R quite a bit on our team because of its capacity for spatial data analysis, in addition to all the survey analysis we'll be focusing on in this session. What we're going to be doing is covering a few of the data manipulation steps that'll be necessary en route to building the kind of model that we hope will answer the research question that Devin's been discussing, which is about how COVID-19 impacted the family planning behaviors for women in the PMA panel study, and then by extension, what we might learn about the broader population of women, reproductive age women in the countries Burkina Faso and Kenya. And just as a reminder, those are the two nationally representative samples that are currently available from IPUMS PMA. We also have samples from DRC and Nigeria as well that are regionally representative, as Phil mentioned. So this presentation is going to be available as an R Markdown file. This is just a R Markdown slides presentation, but all of it is just R code. So we'll make this available for you so that if it's useful, you can use any of the code in your own workflow and just change the samples and variables and things like that. Let's see, we've got a few people in the waiting room. Okay, let's get started. So we're kind of picking up where Devin left off, which is, we've kind of created our data extract through the IPUMS PMA website. And it's very important if you're an R user to remember to select that fixed width data format from IPUMS. That's the DAT file. What you'll actually receive is a compressed data file. It's a GZ file. You don't have to unzip this. You don't need any extra software to decompress the file. We're going to load that right into R. All you really need to do to follow along with what we're doing today is to put the two associated files in a subfolder in your R working directory, which I usually put it in a folder called data. So you're going to download the DAT file, that's your data. And then over here under the codebook menu, which is blurred out, you'll see this DDI link. And that is basically the variable labels and value labels that we're going to be working with in R. So you need both of these files, download them and save them to your working directory. Now IPUMS publishes an R package called IPUMS R to make working with all of this metadata Devin sort of introduced much easier. So you can download this package IPUMS R from CRAN just like you would any other major R package with install packages IPUMS R. And then each session, when you open R to work with an IPUMS extract, you'll just need to load that library. And that library comes with a function called read IPUMS micro for microdata. So we'll specify the DDI file and the data file there. You'll have a different number here, of course. If it's your first data extract from IPUMS, it'll be number 0001, and I've got 93 data files somehow already. But that's the only major difference that you need to change. We'll also be working with three other packages in this session. The first one is actually a suite of packages that most R users are probably familiar with. It's the tidyverse. Includes a graphics package and several other small packages that are extremely useful for data manipulation. In addition to that, we're going to be using the labeled package to work with some value labels. And then finally, we'll be using the surveyor package, which is a tidyverse wrapper around the survey package developed by a statistician named Thomas Lumley to work with survey weights and cluster sample design. So we'll be demonstrating how to do that, incorporate survey weights into your analysis. So we'll begin by kind of considering the analytic sample that we're working with. As Wu Team mentioned, PMA uses this open panel design so that women can enter the panel after phase 1, for example, if they reach age 15 after we've already started. And they can also be lost to follow-up at any phase if, for example, they leave the study area, if they leave the enumeration area. So what you really want to do to start off is take a look at that variable that Devin pointed out, result FQ, and this is the result of the female questionnaire. When we have a wide format data extract, like the one we're working with here, you'll see 2 versions of result FQ. One will have the suffix 1 attached to it, and that's the result of the phase 1 questionnaire. And then the other will have a 2, and that's from phase 2. What you can see here is that in the extract we created, we selected female respondents only, so that everyone who's in our data extract had to complete, one of the 2 female questionnaires. There are other household members on the roster that get dropped from the file, but we have a bunch of NAs here at the bottom. Now these are women who appeared only at phase 2, so there's no record for them at phase 1. But in our wide format extract, we have 1 row for each woman. So these individuals just don't have any data in the phase 1 columns. You'll see that they do have data in the phase 2 columns. That's what those NAs mean. If we look at the same variable from phase 2, you see a different number of NA values. These are people who entered the panel late at phase 2. So there's no phase 1 record for them. But then you also see that result FQ has a number of other codes associated with it that describe why a particular female questionnaire might not have been completed. And these can include things like just declining to participate or any of the reasons that you see here. What we want to do is only include women who completed the female questionnaire in both phase 1 and phase 2. So I'm going to do this with the filter function, and we saw that code 1 equals fully completed. So we'll say filter if both of these variables equal 1. And you can see here how many cases are left. In addition to focusing on women who completed both questionnaires, we're going to be working only with the de facto population of women, and these are women who slept in the household the night before the household interview. You'll find that information in the variable resident. So now these are our final sample sizes, 5,208 women in Burkina Faso and 6,935 in Kenya. So we'll move on now to recoding some of the independent variables that you saw Devin checking out from the website. So I think something that's really important to know if you're an R user working with IPUMS data is that, number one, we have a lot of categorical variables from sort of like select all that apply questions. Often they're dichotomized versions of those questions. If you've worked in R for any length of time, you're probably familiar with working with factors for categorical data, but IPUMS doesn't publish categorical data as factors. We use labeled numeric variables. And the difference here is that you'll see an integer code for each response, and then in these square brackets, we have the value label for that response. And we also have variable labels, which you can pull up at any time with this IPUMS R function. So if you're coming to R from Stata or SPSS, this is probably more familiar than factors would be. We do this for a number of reasons, and I'm happy to answer a question about why we don't use factors, maybe in the Q&A. But we'll be showing you how to work with these sort of special numerically coded and labeled categorical variables. So as I mentioned, we're going to be using that IPUMS R package to do a little bit of recoding. Devin highlighted the fact that we saw a number of not in universe cases in one of our variables, COVID income loss. and that these actually came from women who answered a prior question about whether their household lost any income, not necessarily COVID related. And if they said that they hadn't lost any income of any kind here, for none, this question was skipped. And so those cases are marked not in universe, but you could recode this variable and include them as no, because if they didn't lose income of any kind, it makes sense that they didn't lose any income because of COVID either. So that's what we want to do. Oh, just a reminder, you can always find information about the universe on the universe tab that Devin demonstrated. So here is where we'll be recoding those NIU cases to zeros. Again, if you've worked with R but not IPUMS data, you might just try recoding those 99s as 0. But if you do that, you'll notice that the labels get dumped because of automatic coercion. So what you want to do is work with a function like something from the labeled package, which essentially recodes this value but retains the label. So you can see here now the no label is still attached to the 0. If I had not used labeled, you would not see these labels anymore. You just see 0s, 1s, and 97s and 99s. Okay, so with the remaining codes that are not just valid responses, those 97s and 99s, we'll want to now replace them with NAs. IPUMS R has a little function, label NA if. That's very helpful for this kind of thing. You can use this pronoun for value in a lambda function. That's what that is. And we're saying if the value is greater than 90, we would just like to replace those values with NA. So that, again, that comes from the IPUMS R package. And you can see that that's implemented here. You can also relabel variables with the pronoun label. So you can actually say if the label is no response or missing or NIU, I'd like to turn those into NAs as well. Okay, so once you've sort of finished working with the labels and negotiated, for example, all of the NIU cases, we do recommend then transforming the variable that you're working with into a factor if it's categorical. And what you want to make sure to do is use this version of as factor. It's got an underscore in it. It comes from the 4cats package for working with factors. That's part of the tidyverse that we loaded when we ran library tidyverse. What this does is it takes the value label and uses it as the factor level. So you can see here that our numeric codes are gone and they've been replaced with characters no and yes and NA. The reason we want to transform our numeric variables into factors in the end is because if you do any kind of graphing, you're going to then see the value label rather than the numeric code. You'll see the numeric codes if you forget to turn it into a factor. And it also makes working with dummy variables in regression analysis quite a bit easier as well. Likert style questions can be treated as factors as well. Here's that COVID concern variable that Devin introduced, indicating a woman's level of concern about becoming infected with COVID-19. And this is at phase 2 amidst the pandemic. You can see here that we've got this Likert style scale ranging from not concerned to very concerned, but then you have this code 5, currently or previously infected with COVID-19, and you have a few missing responses. So this time, what we're going to do is use that value pronoun again to say that we would like to label NA any value where the value is greater or equal, greater than or equal to 5. And then I'm just going to speed things along here and pipe that directly to our function as factor. So that gets rid of the 5 and the 98 that we saw, and then turns it into a factor. Okay, so something that we feature a lot on the blog is sort of strategies to make your data cleaning workflow more efficient. And one of my favorite strategies is using the across function from dplyr. Dplyr, again, is one of those packages that gets loaded when you load the tidyverse. And across just allows you to run the same data manipulation function over several variables in sequence. So here I'm saying, okay, across these variables, I'd like to do basically the workflow we saw on our last slide. So this is country, the urban and rural status of the enumeration area where the woman resides, the wealth tertile of her household, and her general education level. So with each one of those, we'll turn the values above 90 into NAs and then course as a factor. So something that everyone does when they start working with categorical variables is they have to learn, how to set a reference group. You can do this with another function from the forcats package. It's factor relevel. So here I'm setting up age in 3 groups. So sort of a young group, a middle group, and an older group. And I do that with case when, and that creates this character string. But I want to make sure that I use the youngest group as my reference group. Factor v level is going to set your levels in the order that you specify here. So this will ensure that the youngest group is the reference group. All right, so much for our independent variables. We're now going to look at our dependent variables. So as Devin mentioned, we're interested in predicting contraceptive method adoption and discontinuation between phase 1 and phase 2. And we're primarily interested in how those COVID-19 variables impact whether women adopted a method or discontinued a method. So we're going to use this variable CP to create basically a dependent variable with 4 levels. So here you can see sort of the breakdown of each of the 4 possible permutations of those 2 variables. We're also dropping any case that either one of these variables was missing, or NIU. I think that's like 3 cases across the entire data set. All right, so we will say that a woman has adopted a method if she was not using one at baseline, at phase 1, but then reported that she was using one when we spoke to her again 1 year later. And she has discontinued a method if she was using one at baseline, but then when we talked to her again a year later, she was no longer using a method of any kind. So here we use case when to identify those cases. And I'm just going to set this up as a factor with factor in by frequency, basically. So whatever group has the largest frequency would be our reference group. So the first thing that you would probably want to do is put together some kind of descriptive statistics table for this variable, and we can do an unweighted, sample description with count. Count is from dplyr, again, another one of those tidyverse functions. So what we'll do here is we'll say, okay, I want you to take my data and group it by country, and then count the number of responses to this variable we created, FP status. And then we use prop table usually to create proportions for each response. So you notice here that the proportions add up to 1 for each of the countries. Now, I don't find this particularly readable, so I always like to make a bar chart whenever I can. I'll make it ggplot2, another tidyverse package. And here's what a very simple bar chart looks like. We'll pass it to this ggplot function where we basically tell it to map the proportion on our x-axis and the different categories of family planning status on the y-axis. And fill is just telling it to also map that y-axis to the color that we're filling. We use geom_bar to draw bars, and this in particular is very important. Using the identity statistic basically tells ggplot to do no further statistical manipulation of the data that we're passing to it. Instead, we've already created our counts and proportions, so we want it to use what we're giving it directly. Why are there 2 bars? Well, that comes from facet wrap, and we're saying we want to facet our data by country. The rest of this is just basically bells and whistles. We like to use theme minimal for a nice clean looking plot. I've gotten rid of the axis title and the legend since those are labeled already. And the last thing is, very commonly you'll want to take those proportions and transform them into percents. There's a awesome package called Scales that will just do all that work for you and apply a percent sign. All right, so that was the unweighted sample statistics, but now we want to do maybe estimation of what's happening in the population. And for that, we want to use our survey weights. Specifically, we'll be using panel weight, which Phil mentioned. It adjusts for loss to follow-up at phase 2. So again, if you're a Stata user, this kind of workflow from the surveyor package will probably be pretty familiar. We use a function called asSurveyDesign to specify elements of the survey design. So we've got the weight here. Then we've got identifiers for each sample cluster. That when we're using the enumeration area ID from phase 1, you could use phase 2 as well, because women had to stay in the same study area between phases in order to be included both times. So it doesn't matter. You can use 1 or 2. Strata is usually urban and rural strata. So this is creating independent variance estimates for women sampled in each stratum. Very small effect on standard errors in this case. We're going to be grouping by country and family planning status. And then we're going to use the summarize function to estimate a survey mean. This also comes from the surveyor package. And what we're doing here is we're saying, hey, we're estimating proportions. And we would like to adjust our confidence intervals so that you don't get any values that are below 0 or above 100%, basically. So if you do that, you'll get a table like this. I'm going to move along a bit quickly here because we've got about 6 minutes left. But you saw that we get a coefficient estimate and a confidence interval. Here, I'm just using the same function that we saw before, but with geom error bar to insert these error bars indicating the confidence interval. I don't think I mentioned, but this is a 95% confidence interval by default, and of course you can adjust that as needed. All right, so finally we'll spend the last 5 minutes on our analysis. So we're going to use that exact same surveyor toolkit to model our dependent variables with this survey GLM function, which comes from that survey package. This is similar to the GLM function that most R users are probably familiar with, except for that it is able to read that survey design information and create cluster robust standard error estimates using the EAIDs that we talked about. So another thing that I like to do on the blog is try not to repeat the same code each time I want to run a model. In this case, I'm going to run a separate model for Burkina Faso and Kenya. I only really want to specify it once, so I'm going to put that code in a summarize function after we've grouped the data by country. And this allows us to basically create one model per country in a nice little tidy data frame like this. So we're going to be saying same survey design, and for the GLM, we're going to be working with this binary version of our dependent variable called adopt. So we've filtered down to look only at women who were not using a method at phase 1. So if we create adopt as a logical indicator of whether our status is adopted, that means the value in adopt is true if a non-user adopted a method, and it's false if, because we only have non-users left, if that non-user was still not using at phase 2. Okay, so this is a binary logit model. And we're going to be specifying this quasi-binomial family. I know this throws a lot of people. You're probably accustomed to seeing binomial, but we use quasi-binomial to basically suppress warnings that R would issue for non-integer outcomes. That's what happens when you use a non-integer survey weight, like the one we're using in panel weight. But otherwise, it's the same logit model that you're probably familiar with. Tidy basically creates a standard tidy data frame output. We're going to exponentiate our regression coefficients. And I'm also using gtools to create just some stars in the table, which you'll see in a second. So you can take that summary output and just grab one of either of the two countries and unnest it. And this is the regression output that we've created for method adoption. What you can see here, because I've added these stars, is that we only found in this particular analysis that the highest level of concern about becoming infected with COVID-19 was correlated with an increased likelihood of method adoption between phases. We also see some significance for the education and age variables. So this is Burkina Faso. If we look at Kenya, none of these measures are significant predictors of adoption for non-users. The story is a little bit different if we switch to looking at discontinuation. In this case, we're going to filter to women who were using at phase 1 and see if they discontinued or they continued using. That would be the inverse. So again, we're just going to use the same code, group it by country, and then we'll throw our same model specification into a summary function, creating a table like this one. In this case, we found that neither of the COVID-19 measures were significantly associated with discontinuation for women who were using a method at phase 1 in Burkina Faso. But in Kenya, we see that generally all of these levels of concern were correlated with a higher likelihood of discontinuation between phase 1 and phase 2. Okay, so we've got about a minute left. That was very fast, and I know it's probably a lot of very IPUMS-specific functions, but if you'd like to see more stuff like this, please check out that IPUMS PMA blog that Devin mentioned up at the top. We feature only examples in R on the blog at this point, so we'll be using the exact same workflow that you saw in this presentation. The IPUMS R documentation website is also extremely useful for understanding what kinds of specific functions are available for working with IPUMS data. And then there's also an IPUMS tutorials page where you'll find all kinds of guides in every language, R, Stata, SPSS, and so on. So thank you all very much. It's been a half an hour. Yep, Laura says we are returning to plenary. So thank you.